Hi, good morning. In this session, we will be discussing index organized table as part of advanced SQL. IOT stands for index organized table. This is a type of table which is available in Oracle database, and this is first introduced in Oracle 9i. The main difference between a normal table and index organized table will be the storage of data and accessing the data from the tables. That is data access and data storage. In these two cases, there will be a lot of difference between normal table and index organized table. Let us take a normal table. When we create a normal table, the data of the normal table will be stored in data segment. That is, we have a normal table, and when we insert data into a normal table, by default all the data of the normal table will be stored in data segment. And when we create an index on a column or group of columns on a normal table, we are creating a normal table and creating an index on either a single column or multiple columns of a normal table. Now, in this case, that is, when we have an index on a column of normal table, that indexed columns data will be copied into index segment. The original table's data will be present in the data segment, and the data of the indexed columns will be copied into index segment also. So, in case of normal table, the non-indexed columns data will be present in data segment only, and indexed columns data will be present in both data segment as well as index segment. So, two copies of data will be maintained for indexed columns of normal table. So, in the index segment, the row IDs will also be stored in the index segment along with the data of the columns. So, now in case of normal table, if we perform any DML write operations on this table, that is normal table with indexes on columns, with indexed columns. Suppose we insert a record into this table. Now, the complete record will go to the data segment, and the data of the indexed columns will be placed in index segment also. If we perform an update, if we update the indexed columns, it has to update the data in two places, data segment as well as index segment. Since the data of the indexed columns is available in two places, that is two segments, the database has to update the data in both the places, data segment as well as index segment. If we delete a record from the normal table which has indexed columns, it has to delete the data from data segment as well as index segment. These are the some of the possibilities in case of normal table if we have any indexes on the normal table. Now, let us take index organized table. This is first introduced in 9i. The structure of the table looks like normal table, but with an additional clause of organization index at the end. This additional clause of organization index indicates that the table is an IOT, which is index organized table. In this case, the data, when we insert data into index organized table, the data will be stored only in the index segment. Data will not be stored in the data segment. That is why when we perform any DML operations on index organized table, if we insert, it has to insert only in one place. If we update, it has to update only in one place. If we delete, it has to update only in one place, which is index segment. Since data is not available in the data segment, it has to update or delete or insert in only index segment. This is one advantage of index organized table. Another advantage, the data will always be stored in ascending order based on the primary key column. There is a restriction also here. Primary key constraint is mandatory while creating the index organized table. For normal table, primary key constraint is optional, but for index organized table, primary key constraint is mandatory. So, the data which is stored in the index organized table will be sorted in ascending order based on the primary key column in the index segment. So, automatically data will be sorted. That is one more advantage. So, data stored in the index organized table is always in sorted order. So, we need not use any order by clause for ascending order if we want to display. Now, let us see. Let us create a normal table and index organized table, and then let us compare the features of normal table and index organized table at the end. At the end of this session, we will be discussing about the differences between a normal table and index organized table. When we refer to normal table, which is heap organized table, heap table. Let us move on to our practical session. We have connected to Scott. Let us set up our environment. The line size we are making as 120, page size we are making it as 500, feedback as 1, width of number column is 5. Let us drop the normal table and index organized table if at all they are present. It is not there. We are using purge option also here, so that it will clean up from the recycle bin as well. IoT was there, we dropped it. Let us first create index organized table without primary key. This additional clause of organization index specifies that this is an index organized table. Everything else will be same. Create table, table name, up to here it is same. This is additional clause, the last one, which is organization index for index organized table. No primary key constraint found. This is the meaningful message. That means primary key constraint is mandatory while creating index organized table. Let us try one more with unique. We have unique constraint. Same error, no primary key. Let us create unique plus not null. Most of the people will assume that unique plus not null is same as primary key. If it is same, while creating the index organized table, since it is expecting primary key, we are defining unique and not null. If that is same as primary key, it should create. It is not creating. This is another proof that primary key is not equal to unique plus not null. Now let us create an IoT with primary key constraint. Table is created. Create one normal table also for just comparison. We have created EMP normal and EMP IoT. One index organized table, organization index, one is normal table. Now describe the tables. When we describe the tables, we do not know whether it is normal table or index organized table. Both looks same. See, there is no additional clause of which type of table it is. It will just describe the structure of the table. Type of the table cannot be known here. Let us select data from both the tables. We don't have any data here. We just created table. Since we have not inserted any data, there is no data in both the tables, normal table as well as index organized table. Now let us insert data into both the tables. We are at insert part. We are inserting into normal table. We are inserting into only employee number column, which has primary key. This is first attempt. Let us see with one column. One column we are inserting into normal table, one column we are inserting into organized table. All rows are inserted. Inserting into IoT as well. We do a commit. Committed the data. Now let us see, select star from normal table. At the same time we select from index organized table also. We are selecting from normal table. It is displaying 1, 5, 2, 4, 6, 3, 8, 7. It is not in sequential order. But when we select from IoT, it is coming as 1, 2, 3, 4, 5, 6, 7, 8. If you see our insert, we are inserting 1, 5, 2, 4, 6, 3, 8, 7. In both the tables we are inserting the values in the same order, not in the sequential order, arbitrary order. But when we see the data in normal table, 1, 5, 2, 4, 6, 3, 8, 7, 1, 5, 2, 4, 6, 3, 8, 7. Data is coming as it is 1, 5, 2, 4, 6, 3, 8, 7. However, we have inserted the data, whatever the order we followed while inserting the data. In the same order, data is displayed in case of normal table. But in case of index organized table, data is rearranged in ascending order based on the primary key column, and then it is displayed for us. So, sorting is present in case of index organized table. Now, let us delete the data. Delete from T underscore normal. Sorry, it is EMP underscore normal. EMP underscore normal. At the same time we are deleting from emp underscore IOT. See, from both the rows we have deleted the data and we committed. Commit is completed. So we have inserted 8 records in both the tables and we have deleted 8 records from both the tables. See, after deleting the data we have performed a commit. Commit is completed. Now the tables become empty now. There is no data in both the tables. See, the tables are empty. Now let us insert the data for all the columns. In our previous example, we have inserted data for only one column, which is employee number of both the tables. But our tables have employee number, employee name, sal, 3 columns. See, all the 3 columns we insert data in the next example. Let us copy this into our file so that it looks nice. Okay, we have deleted the data from both the tables. Now let us insert into IOT. We are inserting all the 3 columns. 1A 1000. It has inserted, 1 row created. Let us insert one more record with the same data. We know that this will not be allowed because of primary key constraint. Duplicate data cannot be inserted, so it is throwing error. 2B 2000 we have inserted, 3C 3000, we have not copied properly. Yeah, 3 rows we have inserted. Let us commit now. Commit completed. We have inserted 3 records. Employee number 1, 2, 3 with all the columns, data for all the 3 columns, and then committed. Now select star from EMP IOT. It has 3 rows. All the 3 records are committed now into the table, into the database. Now let us perform DML write operations on index organized table. Let us see, will they work or not? Update. We are updating non-primary key column, which is allowed. We are updating the salary column, which is non-primary key column. Let us update the primary key column, which is employee number. We are updating the employee number 1 to 4. We are changing employee number 1 to 4. Means we are modifying the data of primary key column, which is allowed, no restriction. Now let us select whether the changes are reflected or not. Yes, 1A 1000 was there, it became 4A 4000. 2B 2000 was there, we updated to 2500. Salary column is updated to 2500. And not only update, because of update on primary key column, the data is rearranged now. Before it was 1, 2, 3, now it became, normally it should be 4, 2, 3, but it became 2, 3, 4 because data will always be arranged in ascending order. So it is automatically rearranged data in the index segment. Let us perform a delete. We are deleting the record 4 where employee number equal to 4. Delete is completed. Let us select. Yes, the changes are reflecting. Delete is happened. Merge will also work. When update, insert, delete, all the 3 operations are working independently, definitely merge will also work on index organized table. Merge is nothing but internally it is an update, a delete and an insert, either all together or individual or with different combinations. Definitely merge will work. Now we have 2 records. Let us commit the data. Data is committed. Can we truncate? Table truncated. Let us see the data. No rows selected. That means we can perform truncate operation on index organized table. There is no restriction. Alter will come later. Can we rename? We are changing the name of EMP underscore IoT to EMP underscore IoT1. Yes, table renamed. Just describe EMP IoT, it should not be there. Describe EMP IoT1, it should be present. Yes. So rename is allowed, no restriction. Can we comment on the table, on index organized table? It is not EMP IoT, it should be EMP IoT1 now. Or okay, rename it back. We have renamed it back to EMP IoT. So now we comment on the table, index organized table. Comment is created. Let us create a comment on the column. Comment on column EMP IoT dot first we create on primary key column. This is IoT we are creating on enum column. Let us create comment on non-primary key column on ename. Creating a comment on primary key column. It is succeeded. Creating comment on non-primary key column, which is succeeded. Let us check the constraints whether they are available. Select star from user tab comments. User tab comments is the data dictionary view where the comments on the tables will be available, where table name equal to emp underscore iot. Yes, it is available. User call comments. This is the data dictionary view where the comments on the columns will be available. User tab comments is for table comments and user call comments is for column comments. We are viewing the comments. Table name we can remove up to here. Okay, first this is comments. One row created.